so now we're going to start solving trigonometric equations. For these next problems, we need the unit circle. Okay, so that's the unit circle. Negative angles. So when an angle is negative, you simply draw your angle clockwise rather than counterclockwise. So rather than going this way with your angle, you draw it this way. And then coterminal angles are two angles with the same terminal side, or side that does not always land on the x-axis. So for example, a negative 90-degree angle, or negative pi over 2, and 270, or 3 pi over 2, are coterminal angles, because they both lie on this line. Let's learn how to find the exact values of coterminal angles. Let's begin with negative 270 degrees. It is graphed on the unit circle here, drawn clockwise since it is a negative angle. Then just by looking at the unit circle, we know the coterminal angle between negative 270 ends up being a 90-degree angle, because the terminal sides land at the same point. Then for the next two, we can find the coterminal angles using mathematics. So to find the coterminal angle, we simply add 360 degrees. And so for number 2, a negative 30-degree angle, the coterminal angle is 330. Then for the final example, since it is in radians, we simply add 2 pi rather than 360 degrees. So then our final answer is going to be pi over 6 as the coterminal angle for negative 11 pi over 6. Okay, so here's a list of our trigonometric functions. We have sine, cosine, tangent, secant, cotangent, and cosecant. Have fun! So the steps to solve trigonometric equations. The first step is, when applicable, rewrite the equation in terms of one function. So if we have sine of theta plus cosecant of theta, we would rewrite it as sine of theta plus 1 over sine of theta, because cosecant is the reciprocal of sine. And then the next step is to isolate the function, or to get the function on one side of the equation alone. The third step is to solve as if the function is simply a variable, and typically it is easier to rewrite the entire equation in terms of x rather than in terms of sine or cosine. And then the fourth step is to, once solved, find your solution on the unit circle. So if I had the solution sine of theta is equal to negative 1/2, I would find where negative 1/2 is on the unit circle, and that would be my answer. So now we're going to do 3 examples of trigonometric equations. So in our first example, we're dealing with cosecant and sine. So our first step is to rewrite cosecant as the reciprocal of sine. So we get 1 over sine of theta plus 2 sine of theta is equal to negative 3. And then to make this equation easier to read and easier to solve, we can rewrite sine of theta as x. So 1 over x plus 2x is equal to negative 3. The next step in solving this equation is to multiply the entire thing by x in order to get the x out of the denominator. So we get 1 plus 2x squared is equal to negative 3x. The next step is to add 3 to both sides, well, 3x. And then we get 2x squared plus 3x plus 1 is equal to 0. And then after we factor, we get that x, or sine of theta, is equal to negative 1/2 and is equal to negative 1. So the next step is to find these values on the unit circle. So we find where sine is equal to negative 1 and where sine is equal to negative 1/2. And it's at 7 pi over 6, 3 pi over 2, and 11 pi over 6, which are our answers. Okay, so in our second example, we are only dealing with cotangent, so we can already rewrite our functions in terms of x, which simply makes it easier. So we get x to the third is equal to x. So then the next step is to subtract x from both sides. And we get x to the third minus x is equal to 0. So then the next step is to simplify the equation. So x times x squared minus 1 is equal to 0. And then we already know that x is equal to 0, or that x squared minus 1 is equal to 0 as well. So since this one is already solved, we simply move on to this one and add 1 to both sides. So x squared is equal to 1, and we take the square root and get that x is equal to positive or negative 1. So then the next step is to find these values on the unit circle. So we find where the cotangent value, or the reciprocal of tangent, is equal to positive or negative 1 and 0. And these are at pi over 2, 3 pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, our final example is using sine and cosine, which are not reciprocals of each other, so we cannot rewrite either of the two. So our first step is simply going to be rewriting the function in terms of x and y rather than sine and cosine. So we get x minus y squared times x is equal to 0. The next step is to pull an x out of the equation. So we get x times 1 minus y squared is equal to 0. So then we already know x is equal to 0 because we simply pull these two. And then we also have to solve for y. So we get 1 minus y squared is equal to 0. We subtract 1 from both sides. We get negative y squared is equal to negative 1. Divide by negative 1. Y squared is equal to 1. And then finally we know y, or cosine, is equal to positive or negative 1. And that x, or sine, is equal to 0. So then we go to the unit circle and find where sine is equal to 0 and where cosine is equal to positive or negative 1, which happen to be the same spots. Okay, so now you try. We've created Quizlets on practicing solving radical equations, which is the first Quizlet, and solving trigonometric functions, the second Quizlet, and have left the links below.
Math is fun.